when you verify an identity, let me see if I can move this up here. When you verify identity, listen. Okay, when you have verified identity, all you have to do is get one side equal to the other. And it's like simplifying, Jacob. It's like simplifying. So here's the objective. Today we'll use what we know about simplifying trig expressions to verify identities. So we have been simplifying these expressions. And all we're going to do now is we're going to put an expression on each side of an equal sign, and we are going to simplify them until they're both the same. And then that's called verifying an identity, or establishing our identity, or proving an identity. Depends on what textbook you look at, which mathematician you listen to. But that's all we're doing. So pretend like, the only difference here now is you are given the answer at the end. Does that make sense? Here's like what we've been doing on the left side, and it's giving you the answer. This is what you're supposed to end up with when you simplify the left side. So how many of you simplified this left side? Okay. What did you do with cosecant? Okay, 1 over sine of theta. What did you do with tangent? Sine over cosine. Now, I showed you the other day how to do these in order so it's nice and neat. Okay? So what happens right here? An algebraic manipulation. Okay, the signs cancel out. And what does that leave me with? Okay, so now I have 1 over cosine. Now, as I'm doing this, you guys, I keep bringing down the right side as well. Now, what's next? 1 over cosine equals secant. So I'm going to write it down here. I can just write it like this. Secant of theta equals secant of theta. Well, technically, you should do this step right here, because what you're doing is you're taking the left side down until it becomes the same thing as the right side. So all we did is simplify the left side until it became the secant of theta. That's all we're doing. Okay? Well, say that again, Caleb. Yeah. Yeah. Well, yeah, then it would not be a true identity. And then we've proved that it's wrong. We're trying to prove that they're right. And I'll tell you up front, you guys, all of these identities, Sierra, all these identities are true. Zach, all these identities are true.
You know what the answer is.
It just gives you the answer. All you have to do is find the method to prove them. Okay? All right, I'm going to answer questions on 7-1, and then we're going to turn it in. So I'm just going to answer a few. So if you've got them, get them out. Okay, so right here we have problem 50 on your last assignment. You guys, some of these there's tricks too. This one is not. It's not really a trick. You have to start off with an algebraic manipulation. Actually, probably it'd be better to change this cosecant and this cotangent to sines and cosines. Okay, so let's do that first. So we have 1 plus the cosine of theta. What can I change cosecant to? 1 over sine, good. What can we change the cotangent to? Well, cotangent's not a sine or cosine. We're going to use a quotient identity. So what is it? Cosine over sine. Okay, now, I noticed something here. You guys notice anything about the right side, this right set of parentheses right here? What could we do? Common denominator, yeah. They both, we're minusing this, and they have a common denominator. Can we combine them into one fraction? Okay, so we have 1 plus the cosine of theta. Well, 1 minus the cosine of theta all over sine of theta. Okay. Now, that's probably a good way to start. And by the way, there is more than one way to do these. I could have started off multiplying these two together. As long as you're trying something, it's usually going to work out, okay? Now, what do you think I should do next? Does anybody have an idea? Think about what's distribute. That's exactly right. I'm going to times this 1 plus cosine by the 1 minus cosine over sine. Now, since the right one is a fraction, the left one is not, I can make the left one into a fraction by doing what? Put all over 1. Now, when you multiply two fractions together, how do you do that? Well, you multiply the numerators together, that's the tops, and then you multiply the denominators together, right? So I've got to times 1 plus cosine by 1 minus cosine, and I have to FOIL, or I actually like what Dakota said better. I like to think of it as distributing, multiplying. Because if you have more than one or more than two terms, you still have to distribute it, and you can't call it FOIL. Okay, so we're going to times. 1 times 1 is 1. 1 times negative cosine is negative cosine of theta. Cosine times 1 is cosine. And cosine times negative cosine is negative cosine squared. And then on the bottom we have 1 times sine of theta. Now, do you see anything we can do right here now? Combine like terms on the top. What is that going to give us if I combine like terms on the top? Yeah, because these two in the middle add up to 0, don't they? So 1 minus the cosine squared of theta all over the sine of theta. Because these two in the middle, no, these two right here, negative cosine plus positive cosine make 0, right? They're opposite numbers. You're adding two opposite numbers. It's like adding 2 and negative 2. We went like this. I distributed the 1. I times 1 by 1 and got 1. 1 times negative cosine and got negative cosine. Then I times cosine by 1 to get cosine, and cosine by negative cosine to get negative cosine squared. And then I combine like terms on the top. Now, you guys, the rest of this problem is kind of like one that we did the other day. What is 1 minus a cosine squared? You have an identity. Huh? Close. Sine squared, yeah. So that's sine squared. So I'm going to replace 1 minus the cosine squared with sine squared of theta over the sine of theta. Now I'm going to go off to the right just to save room right here, you guys. What does sine squared of theta mean? What is the squared telling me I'm doing? I'm timesing it twice. So sine squared of theta means sine of theta times sine of theta all over sine of theta. What happens? Yeah, one of the signs on the top cancels with the sign on the bottom. So what's my answer? It comes out to be sine of theta. Okay? Now, I want to talk about what we're going to be doing today. If I was doing this problem today, instead of being written as 1 plus cosine theta times cosecant theta minus cotangent theta, what would be different about this? It would be equal to sine, right? Like Caleb said. All we'd take is, we would know the answer. I would put the sign up there, put equal sign, and you would know the answer. All you have to do is simplify the left side to be the right side. So do you see that what we're doing today is the same as what we've been doing? It's just they give you the answer. It's actually easier. So you know what your end product has to be.
Give us the answer for all of our assignments only here.
Huh? I did. I gave you mostly odd problems. They're always in the back. You can check your answers to see if you're getting them right. Okay, any questions? 31. Okay, so number 31, you guys were given that sine of theta equals negative 1/3. We're supposed to find the tangent of theta. So find the tangent of theta. And it gives us one other piece of information. It tells us which quadrant it's in. Which quadrant is it in?
180 to 276 in the third.
So 180 to 270, which is in the third quadrant. So my answer has to be an answer in the third quadrant because I'm probably going to get, I might end up getting two answers here. I just got to know which one is the right one, okay? All right. By the way, okay, so I'm given a sine. I want a tangent. Okay, you guys, is there any identity that has a sine and a tangent in it? Look at your identities, your basic ones. Are there any identities that have a sine and a cosine in it? Look at your identities. Okay, so there's the identity that says sine over cosine equals tangent. That's the quotient identity, right? So if I knew the cosine, would I be able to use this identity? Yeah, to get the tangent. So what I need to do is find the cosine first. Is there an identity with a sine and a cosine in it? Which identity? Well, the cotangent, yeah, but I'm saying only a sine or cosine. Is there one with just a sine and a cosine? Nothing else. No, tangent has three things. Look at your identities and see if you can find one identity that has only a sine and a cosine. Yeah, that's it right there. Sine squared of theta plus cosine squared of theta equals 1. So I'm going to make a substitution here. I know sine of theta, so what am I going to substitute? I'm going to substitute negative 1/3 for sine. That just leaves me the cosine in this equation. I can solve when I have one variable, right? So how am I going to solve and get cosine by itself? Well, not 1/3. Yeah, I'm going to square this first. So what is negative 1/3 squared? It'd be negative 1/3 times negative 1/3. You guys, what's negative 1 times negative 1? What's 3 times 3? So what is this going to be? 1/9. Then what am I going to do? Okay, I'm going to subtract 1/9 from both sides. I get cosine square root of theta equals 1 minus 1/9. What is 1 minus 1/9? It's 8/9. Because I can change 1 to what? 9 over 9, right? 9 over 9. So 9 minus 1 is 8, and you get 8/9. So cosine squared of theta equals 8/9. Square root both sides. Good. What does that give me? Cosine of theta equals plus or minus. Do you remember that? Plus or minus the square root of 8 over 3. Let me ask you this, though, you guys. Because we can separate the square root of 8/9 and the square root of 8 over the square root of 9. We know that the square root of 9 is 3. 8's not a perfect square, but can we break 8 down? What does 8 break down to? Whoops. 2 and 4. And what does 4 break down to? Yeah, so I have a pair of 2's, a loner 2. So these two are go on the outside, and the loner goes inside 2 root 2, right? So what's my answer going to be? 2 square root 2 over 3, right? So now the question is do I want my positive or my negative? Why negative? Okay, because it's in the third. My answer is in the third quadrant, you guys. And I'm going to be using this identity to find the tangent. And I already know sine is negative. And sine is negative, cosine is negative. That will make a positive tangent. And tangent's positive in that quadrant, right? Is a negative over negative is a positive? So I want the negative of that. So now I'm going to use this identity right here. I'm going to erase this. I'm going to use this identity right here. I'm going to plug in sine. Sine is negative 1/3. Cosine is 2 root 2 over 3. And this is equal to tangent, right? Oh, negative 2 root 2 over 3, right? And because I know the tangent is positive in the third quadrant, the only way that happens is if you divide a negative by a negative. How do I simplify this? A fraction divided by a fraction. Okay, I multiply it by what? 3 over negative 2 root 2. Good. The reciprocal. What happens right here? Okay, the 3's cancel out. What do you get? What about, there's a negative on top, negative on bottom. What happens to those? Well, a negative divided by negative is positive. So what am I going to get? Positive 1 over 2 root 2. Remember, these things cancel out and you still have a 1. Okay, we can't have a root on the bottom, so what are we going to do? Times top and bottom by what? Just square root of 2. Square root of 2 will work. 1 times root 2 is root 2. And 2 times root 2 is 2 root 4. What's root 4, though? It would be 4 on the bottom, wouldn't it? Because square root of 2 times square root of 2 is 2, times that 2 is 4. There's your answer, root 2 over 4. Well, it just seems like a lot of work because I'm explaining it and I'm writing down every single last step. Well, I know Eddie's head is big, but I don't know about Miranda's. Well, Miranda took 4th place in this Trig Star contest, so her head's been getting a little bit big lately. Do you guys know Kevin Young?
Yeah.
Kevin Young won it.
You did?
Yeah. Yeah.
You got $500?
$200. Well, there's 3 people that got 76, but he turned his in first. The other guys kept trying number 4, and I think Kevin got to number 4. He did the first problem because the first problem was pretty easy. Everybody got that one, but he knew it was a time test, and he knew he got the first 3 right. He was pretty confident in that, so he just turned his test in, guessing that people wouldn't get the 4th one, and he was guessed right. Yeah, that's all right. I'll announce it right here. Kevin Young took first. G.D. Gates took second. And Tyson Ashcraft took third. And Miranda tied for 4th with Sam.
No, I would have won, so I was a couple seconds faster.
Okay, Sam Allen, but Miranda turned hers in first. Okay. Actually, Sam turned his in with at 60 minutes. You turned yours in before that, didn't you? Way before that. Yeah, so Miranda actually took 4th. There was 13 people that took the test. Yep. All right. Any questions there, you guys? Is 52 similar? What does 52 say? All right, hey guys, 52 is an interesting problem. You're going to see some on your identities today. On your identities today, you're going to see some of these. So kind of watch this. There's a trick. It's not really a trick. We just got to get a common denominator and add these together. Raise your hand if you can see what the common denominator is. It's not cosine. It's not 1. You have a 1 minus cosine x here and a 1 plus cosine x here, right? The common denominator is those 2 times together. So this side right here, you guys, I'm going to have to times this side by 1 minus cosine x. The top and bottom. Because what? That's a 1, right? Remember that? The number divided by itself is 1. When you times something by a 1, it doesn't change its value. It just changes what it looks like. Over here, I've got to times this one by 1 plus cosine of x. That way, I'm going to have a common denominator, and I can add these together. You guys, anytime you see a plus sign with fractions, you got to think, get a common denominator and add these together. Combine them into 1. Okay? So, if I distribute right here, on the top, I'm going to distribute this. 1 times sine of x is sine of x. And negative cosine of x times sine of x is negative cosine of x times sine of x. Plus, over here, sine of x times 1 is sine of x. And sine of x times cosine of x is positive cosine of x times sine of x. All under this denominator. You guys, we can combine this because we know we're going to have a common denominator on the bottom. And I'm just going to do it all at once here. And if I multiply 1 times 1, I get 1. 1 times cosine of x, I get cosine of x. Negative cosine of x times 1, I get negative cosine of x. And negative cosine of x times cosine of x, I get positive cosine squared of x. Now all I have to do is simplify this, and probably substitute an identity, I'm guessing, at the bottom. When I get it simplified, I'll see the identity. So right here on the top, do you guys see anything that will cancel out? Do you see anything that is opposites?
Negative cosine? No, positive negative cosine.
Yeah, see this right here and this right here? Those are opposite numbers. They add up to 0. So what does that leave me with on the top? Sine of x plus sine of x. Is sine of x plus sine of x sine squared? What is it? It's 2 sine of x. Yeah, you guys, you're adding them. So you guys remember when you're adding things and they're the same, you can change it. Like sine of x plus sine of x is 2 sine of x. But sine of x times sine of x is sine squared of x. When you're timesing two things together, you can put them as an exponent squared. If you're adding things together that are the same, you multiply it by 2. So the top just becomes 2 sine of x. What about the bottom? Do you see anything that cancels out? On the bottom. Yeah. Cosine of x minus cosine of x. So I get that. Wait, you know what? I did that wrong. Right there, you guys. I made a mistake. See this plus right here? Should be a minus. Does anybody know why? Why is that a minus? Cosine of x times a negative cosine of x is a negative cosine squared of x. Okay, here we go. There's an identity with 1 minus cosine squared of x. What is that identity? What identity is 1 minus cosine squared of x? We've probably only done this one 10 times. Huh? Yeah, it is. Sine squared. Okay. So I have 2 times the sine of x over sine squared of x. What does sine squared mean again? Yeah, you're timesing 2 of them together. So it gets 2 sine of x over sine of x times sine of x. And one of them cancels. And what do you end up with? You end up with 2 over sine of x. Now, you guys, I can write this as 2 times 1 over sine of x. And what is 1 over sine of x? Cosecant. So my answer is going to be 2 times the cosecant of x. And I'm done. So here we are. I've already kind of talked about this on the bell work. But we're going to verify trig identities using the basic identities. So what does it mean? Don't write this down, other than the objective. What does it mean to verify identities? Think about that for a second. I've talked to you about what does it mean to verify identities? Make both sides equal. Okay, prove that it's true, right? Okay, it means to transfer one side of an identity into the same form as the other side. How is this done?
Using basic trig identities properties of algebra.
Yeah, so let me explain. You guys, we have been doing this already, but let me rephrase it again, just to make sure you understand. We're going to take the identities that we already know, like the Pythagorean identities, the quotient identities, and the reciprocal identities, and we're going to use them to make substitutions in for things. Then we're going to use our algebra skills to simplify them. You've got to use algebraic manipulations to simplify them. Okay? That's what we're doing. So, right here, suggestions for verifying. I want you to start with number 1. I want you to write these down. Okay? Number 1. Transform the more complicated side of the equation into the simpler side. In other words, start on the side that looks more difficult or longer. Okay? Sometimes they are both difficult. Sometimes it's hard to tell which side is more difficult, so you just start with either side. But most of the time, one side is long and one side is short. So you're going to start with the long side and simplify it to be the short side. That's what that means. Okay, next thing, right here. Then we're going to substitute one or more basic trig identities to simplify the expressions. Okay, like, for instance, you can replace a cosecant with 1 over the sine using the reciprocal identity. Or you can replace a tangent with sine over cosine. That's what it means to substitute one or more basic trig identities. Or you can substitute for sine squared of theta plus cosine squared of theta, you can substitute 1. There's a lot of substitutions you have to look for. You guys, if you memorize the identities, it'll make this so much easier because you will see something and say, I know that there's an identity for that. And you can think of it and you can substitute into something simpler, and it makes it a lot easier.
It sounds like memorizing, or is there like a trick?
Well, there's just no. We've learned how to do. You know, we've learned all along that sine and cosecant are reciprocal identities. So you just got to remember, sine and cosecant are reciprocal identities. So sine equals 1 over cosecant, or cosecant equals 1 over sine. So just things like that. You should almost have them memorized by now.
Yeah. My sister taught me this thing. It was like the third letter in every one is like the starting of the other, like, so cosecant with.
Okay. Next thing. Sometimes, you guys, you have to factor. Sometimes you have to multiply. You just got to look to see what's going to help you out the most. Sometimes you have to factor, sometimes you have to multiply. You just got to look for algebraic manipulations that you can do. Okay? Fourth one. Sometimes you can multiply an expression by an expression equal to 1. Remember how we multiplied a fraction by 1 plus cosine over 1 plus cosine? We just did an example like that a little bit ago. That's a 1, but it changes what it looks like, and so it helps us to put it in a different form that will help us to solve it. And the last one, number 5, says express all trig functions in terms of sine and cosine. This one almost ought to be one of the first ones. Usually, it's easiest to transform everything into sines and cosines. Not always, but sometimes it is. Most of the time it is, actually, but not always. So those are some tricks. Guys, these are just tricks or ideas, something that you can do to start a problem. If you're stuck, go read these 5 things and say, which one of these can I do? Okay? Which one of these 5 things could I do to help out? I was just making it up there, so some of you guys are trying to look around everybody there. Okay, important note. Don't write this down. It's just something to think about. You cannot add or subtract quantities from each side of an unverified identity, nor can you perform any other operation on each side as you often do with equations. An unverified identity is not an equation, so the properties of equality do not apply. In other words, you know how when we're solving equations, you guys, I get kids that do this all the time, so don't do this. If you do this on the test, it's wrong. You can't, since it's not a verified identity, you can't say, okay, I'm going to minus cosine from both sides of this. You can't do that. You can only work with one side at a time. You can't do the whatever you do to one side, you do to the other side thing. Got it? Okay. Right here, next. We are going to do an example here. Verify this identity. Okay, this says, you guys just, because sometimes it's hard to see back there which things are minus and which things are times. Everybody write this down. Secant squared of x minus tangent of x times cotangent of x equals tangent squared of x. You guys are going to figure this one out. I'm going to come around. Remember, which side it looks more complicated here? The left side. Okay? The right side just says tangent squared. I've got my answer. I want to get this to be a tangent squared. The left side, I've got to simplify to be a tangent squared. So I'm going to manipulate the left side. I'm going to simplify it, and you should get a tangent squared by the time you're done. So just like what we've been doing, just so we're going to work with the left side. You guys in your groups are going to do this. Go. So most of you guys thought about it. There's about 3 or 4 different ways you can do this one. Let me show you 2 ways. Okay, Jacob? Let me show you 2 ways. The first way, the secant squared of x. I'm just going to leave it as secant squared of x this time. Minus, you guys, the tangent of x using the Pythagorean identity can be, not the Pythagorean identity, the quotient identity can be changed to sine of x over cosine of x. The cotangent can be changed to cosine of x over sine of x, okay, equals the tangent squared of x. Now, a lot of us, you guys got right here and you weren't sure what to do. Well, you guys, how many times does sine go into sine? Once. How many times does cosine go into cosine? What's 1 times 1? So now I have secant squared of x minus 1 equals tangent squared of x. Now, what's secant squared of x minus 1? Yeah, it's a Pythagorean identity. And you're done. You've got one side equal to the other side, you're done. One of your identities says secant squared of x minus 1 equals tangent squared of x. So you can replace this secant squared of x minus 1 with tangent squared of x. Okay, Kendall, you got to just write down all the identities. That's the problem. You don't have them all written down. Yeah. Well, you don't have the names of them. You don't have anything, so you're not knowing what I'm talking about. So just write them down. I would definitely write these on your 3x5 card. Yes. You'll definitely want all these on your 3x5 card for the test. Okay? Let me show you guys another way to do this. I could have done this one by changing the secant squared of x to 1 plus the tangent squared of x, using that identity. Then Doing the same thing I did down here and getting 1. Remember that? Where we, with the tangent times the cotangent. Tangent, cotangent are reciprocal identities. So when you times them together, you get 1. Did you guys ever think about that? Tangent times cotangent are reciprocals of one another. When you times them together, you get 1. Okay, now this 1 and that -1 add up to 0. So you get this. Now I skipped a step there. If I was doing this on a test, I couldn't skip that step. I just skipped it because it was already written right here. Okay? There's even more ways than that to do it. Okay? All right, next one. Okay. I would suggest on this one changing everything to sines and cosines. Then simplifying. Using your algebraic manipulations. That was very impressive. How many of you guys got it? If you're still struggling with it, watch. There's more than one way to do this one. But a lot of you guys noticed right away that that's a Pythagorean identity. If you notice that, that made it so much easier. What is 1 plus the tangent squared of x equal to? Yeah. See, you guys, if you have those identities memorized, you would have noticed that right off. And then you could say, okay, that's a secant squared of x. Okay? Then, you guys got to this part right here. And then you noticed, well, hey, that's secant of x. We'll cancel with one of those on the top, right? So now we have secant of x over cosecant of x. You got that far. And then, some of you guys said, well, secant of x, using the reciprocal identity, was 1 over cosine. And cosecant is 1 over sine. So you have 1 over cosine times sine over 1. Whoops, sine over 1. Well, that just makes what? Sine of x over cosine of x, which is equal to what? Tangent, which is what the right side equal to. Okay, now, when you guys take the test, I've got to be able to follow your work. So make sure it's nice and neat, okay? All right. Okay, you guys were impressive. That was really good. See, some of you guys are starting to learn this. Okay, here's the next one. Okay. Now notice, both sides right here are kind of long, but one's more complicated than the other one. Which one's more complicated? The one with the division, right? So this one right here, this one is you guys, notice that everything is sine and cosines on this one. This one's algebraic manipulations mostly. That's what it mostly is, algebraic manipulations. You know, you guys, for some of you, it might be easier to get the right side in sines and cosines. I actually, just because I know of algebraic manipulations, I can see exactly what we'd have to do, but I wouldn't expect any of you to probably get this one using the left side. You might be easier working with the right side for you guys. The left side would be really easy if you know one algebraic manipulation to do. But maybe I can show you. I just want to show you this. I just want to show you this. You guys, if you have 5 plus 7x, I shouldn't use 5 and 7 because those are numbers up there. Let me do something like this. 6x plus 5. And on the bottom, you had 4y. Okay? Let's say you said something like that. you guys know, since everything down here is being timesed, and you have two things up here being plus, you can separate those into 6x over 4y plus 5 over 4y, couldn't you? You can do the same thing on the left side right here, because everything on the bottom is being times. You can separate those, and that's the trick. If you know that trick, this one's a pretty easy problem, actually.
Wait, I'm almost there.
All right, hey, you guys, this one was easier than it looked. Right here, watch. I'm going to take the left side, and I'm going to separate it into two fractions. Since I have one denominator on the bottom, I can separate it into two fractions. I told you guys this will help strengthen your algebra skills. I told you to do this. No, I said do this. You said, should I add them back together? That's what you said. Okay, that cancels out, right? So it leaves me with 7 over cosine. Those cosine, oh, whoops, I canceled the sine. Sorry, the cosines cancel out. I still have a sine, so it's 5 over sine. You guys, I can write this as 7 times 1 over cosine, right? Plus 5 times 1 over sine. No? Cosine's on the bottom, right?
Yeah, but if you're timing it,
What is 1 over cosine, you guys? It's secant. So you get 7 times secant of theta. Plus, and over here, what's 1 over sine? Cosecant. So 5 times cosecant of theta. And there's your answer. That's what that is. What are these magical ones? Well, let me ask you. If I times sine times 1 over cosine, what would I get? You get 7.
but if you're dividing,
Okay, if I times 7 by 1 over cosine, I'd get 7 over cosine right up here, right? All I did is I separated these two. I made it into a multiplication problem. So that you guys could see that this was a 1 over cosine, so you can see it was a secant.
but if it's 7 divided by cosine should be like cosine over 1, right?
No, it's 7 times 1 over cosine. This is 7 divided by cosine, right? Which is the same thing as 7 times 1 over cosine.
Oh, never mind. I had it backwards.
Yeah.
I thought if you were to multiply, it'd be cosine on top.
No, if you multiply, you're going to go 7 times 1. This is not a fraction divided by a fraction. Okay? All right? Okay, hey, you guys. We have 2 examples left, but we don't have time for them. So here's your assignment. Here is your assignment. Lesson 7-2, page 434, 13 through 27 all. You guys, we're going to spend a couple of days on this, and we're going to do some cooperative learning activities in your groups. You will get this down if you try. Okay? All right, have a good weekend.